Pythagorean Theorem and its converse. Okay, Pythagorean Theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So a squared plus b squared equals c squared, where c again is the hypotenuse. Okay, so solving for x in this first example. One leg squared plus the other leg squared equals x squared. So 49 plus 16 equals x squared. I have 65 is equal to x squared. X is equal to the root of 65. B, one leg squared plus another leg squared equals my hypotenuse squared. So x squared plus 64 equals 144. I subtract 64 from both sides and I get 80. Again, I square root and I want everything in simplest radical form. In simplest radical form, that is 4 root 5. Okay, Pythagorean triples. Some common Pythagorean triples, or Pythagorean triple, I should say, is a set of 3 whole numbers. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on are whole numbers that satisfy our Pythagorean theorem. 3, 4, 5 is a very common Pythagorean triple for us. 5, 12, 13, very common Pythagorean triple. 8, 15, 17, 7, 24, 25. And then what all these ones down here are, is these are just multiples of that. I multiplied each one of the sides by 2, 3, 4, 5. Okay? Because those triangles then are going to be similar. So there's still going to be a Pythagorean theorem because I still have some common, the angles are going to be the same, so they're similar, but keep in mind that these are all basically multiples of my common Pythagorean triple. Okay, example 2. Use a Pythagorean triple to find x. So 24 squared plus x squared equals 26 squared. That'd be really hard to do, and I probably wouldn't give you guys a calculator on this. But what you have to recognize is, hey, 24. Hey, well, that's 2 times 12. 26 is 3 times 13. Let's go back to my Pythagorean triples. Do I have some of them? Do I have I have right here a 5, 12, 13. So this side, the third side, is 5 times x. And I realize I have a mistake here. This isn't 3 times 13, that's 2 times 13. So this is a 5, 12, 13 Pythagorean triple that's been multiplied by 2. So I have 2, 2. That x there is really standing for 2. That x there, I should say, is 2. So I have 5 times 2. That last side length is 10. Okay, example 3. A 20-foot ladder is placed against a building to reach a window that is 16 feet above the ground. How many feet from the building is the bottom of the ladder? Okay, 20. 20 is 5 times 4. 16 is 4 times 4. So I notice how I have 2 common numbers. And from my Pythagorean triples, I have a 3, 4, 5. So this is a multiple of a 3, 4, 5 right triangle. What's my multiple? My multiple is that common number, that 4. So I have 3 times 4. That's going to get me 12 feet. Now, yes, again, you could use the Pythagorean theorem, but you're going to be doing a lot more challenging math that you really need to do on this. Okay, classifying triangles with the Pythagorean theorem. So if c squared equals a squared plus b squared, we have a right triangle. Okay? If that c squared is less than, so if that longest side in my triangle is less than the sum of the squares of the others, we're acute. If it's greater than, we're obtuse. Determine whether these side lengths can be used to determine a triangle. If so, classify the triangle as acute, right, or obtuse. So this is some fun review. Remember, two sides of the triangle have to add up to be larger than the third. So 9 plus 12 is definitely greater than 15. 12 and 15 definitely greater than 9. And then lastly, what was my last one? 9 and 15 definitely greater than 12. So we have a triangle. So now we have to determine the type. So take your two smallest sides, add those together, determine how that relates to the square of the third side. So 9 squared plus 12 squared is 225. 15 is 225. They're equal. I have a right triangle. Okay, again, take the two smallest sides. Do they add up to be larger than the third? Yes, they do. So we have a triangle. So the squares of the two smaller sides, the sum of the squares of the two smaller sides. How does that relate to 13 squared? 13 squared is 169. This other side is 221. So c squared is less than, we are acute. The third one. Okay, 2 and 4 add up to be 6. 2 plus 4 equals 6. 6 is less than 7. No triangle. Okay, for this one, square root of 59. So let's just take an estimate. Okay, it's between the square of 7 and the square of 8. And it's about halfway in between, I would say. So I'm going to say that this is approximately 7.5. It's a little bit more than that. Don't worry about that. This 195, okay, square root of 195 is somewhere between 13 and 14. 14 squared is 196. So 13 squared is 169. I just think that's something that's really cool. So I'm going to say this is approximately 13.6. Okay, those two sides, those two smaller sides add up to be bigger than 16. So we have a triangle. So I take my two smaller sides, square root of 59 squared plus the square root of 195 squared. How does that compare to 16 squared? So I have 59 plus 195. How does that compare to 16 squared, which is 256? This is 254. is less than 256, so this is an obtuse triangle. Okay, determine whether MAT is acute, right, or obtuse for the given vertices. So I need to find the lengths of each one of those sides. So MA, the length of MA, I use my distance formula. And I get 3 minus a negative 2 squared plus 3 minus 5 squared. That ends up being the square root of 29. I'm not going to go through the distance formula. I'm actually recording this in October of 2021, and my guys are struggling with the distance formula right now. So I'm kind of sick of the distance formula. AT, 5 minus 3 squared plus negative 2 minus 3 squared. That ends up to being root 29. And then MT, again, the distance formula, 5 minus a negative 2 squared plus negative 2 minus 5 squared. That ends up being root 98. Okay, so I have, let's see how the two smaller sides. So square root of 29 squared plus the square root of 29 squared. How does that compare with the square root of 98 squared? So I have 29 plus 29. How does that compare with 98? So this is 58 and this is 98. My C, it's funny, I have that 58 is greater than 98. 98 is definitely greater, so my C is greater. We are obtuse. In my notes I had this symbol reversed. I don't know what I was doing there. Yeah, I don't know what I was doing. Okay. Example 6. Solve for x in the triangle below. So, we know we have a right triangle because I have a right angle symbol there. One leg squared plus the other leg squared equals the hypotenuse squared. So x squared plus 9 squared, I'm going to change that 9 squared to an 81, is equal to x plus 3 times x plus 3. I'm going to FOIL that out. First term, outer term, last term. So I have x squared plus 81 is equal to x squared plus 6x plus 9. If I subtract x squared from both sides, those cancel. I'm going to subtract the 9 over to the 81 to get 72 is equal to 6x. I divide by 6, and I get x to equal 12. Okay, that is my video on the Pythagorean Theorem and its converse. Thank you for watching.